parts of being a father that I really enjoy is sharing experiences with my kids. In particular, I really enjoy the toys, sharing the toys that I played with as a kid with my kids. Sometimes the toys my kids have now aren't as good as the toys I had. Remember Tonka trucks? Remember how you probably played with a metal Tonka truck, but your kid's probably playing with a plastic Tonka truck. That plastic just doesn't hold up. When you load it up with gravel, it deflects and makes bow shapes, and it's just not nearly as much fun to crash into other Tonka trucks. But other toys are a whole lot better. Consider the product by Magic Tracks. This car is so simple. My son, who is 2, can operate it by himself with a single push of the button. Yet the car is able to climb steep inclines, take sharp corners, and the track is able to change dynamically. So today we thought we'd take an opportunity to use this Magic Track product to show 3 types of analysis that InnoSolve uses every day to help our customers solve some challenging problems. The first technique we're going to take a look at is trajectory analysis. This analysis is really powerful. It allows us to track a body and get in its given position, and also determine where it is going and where it has been. The second technique that we will use is a local coordinate system. This technique allows us to track a body in 3D space along its translations, but more powerfully the rotations. And when coupled with other bodies that are moving within the field of view, we can calculate relative 6 degree of freedom transformations to help us really understand the physics of what's going on in your part. The third technique we'll take a look at is vector analysis. This is really useful for a translating body that is moving throughout the field of view. So, without taking more time, let's take a look. Alright, here is a standard video of the car traversing the track. The car starts and goes around in a clockwise manner around the track. The track is supported by a standard optics table and has a hill on the right hand side and several curves throughout. We're going to focus in on the yellow, blue, yellow section in the middle of the track. Here's the trajectory analysis for the car. As you notice on the right hand side, the car comes into the image. It's coming down a hill, so it takes a very treacherous path, and we see this clearly in the trajectory that is swept. As the car recovers, it then takes the corner, but as the car corners, the track slides a little bit. However, all this makes sense because of this trajectory analysis. Here's a local coordinate system analysis. As you see the car come in on the right, going down the hill, the coordinate system stays fixed to the car and gives us tremendous insight into the translation and the rotation of the body. As the car straightens out around the curve, we say the coordinate system stays fixed to the car. This type of analysis is really powerful when there's many bodies moving around. This local coordinate system will stay fixed to each of the local bodies and allow us to perform 6 degree of freedom relative motion analysis between multiple bodies simultaneously. Here's a velocity vector motion analysis. This is really useful because it shows us the rate of change of the displacement vector. And so as we expect, as the car takes the corner, we see that the velocity vectors are pointing in a direction that's normal to the center of that curve. I hope you enjoyed our video analysis of Magic Track's glow-in-the-dark race car toy. All high-speed video was shot at 250 frames per second. InnoSolve is capable of shooting at much higher rates if your application demands it. I hope you understood the 3 methods that were showcased in this analysis. The 3 are, again, trajectory analysis, local coordinate system analysis, and vector analysis. At InnoSolve, we of course can do many other techniques, but wanted to showcase these 3 in this video series.